Next we will see another problem in tutorial 3, problem 4.4. The charges plus q and plus 3q are separated by a distance 2 meter. A third charge is located such that the electrostatic system is in equilibrium. Find the location and the value of the third charge. So first of all we will be drawing the scenario. So you have the charges plus q and plus 3q which are separated by some distance which is d. Let's say this d is equal to okay, it is given that it is d is equal to 2 meter. Now what is the question? A third charge is located somewhere. A third charge may be some charge here, or maybe here, or it can be put here. It is located such that the total system is in equilibrium. Okay, the whole system is in equilibrium. So find the location and the value of the third charge. That is the question. So let us assume that I put the charge in between these two charges first. Okay, so I put the charge, the third charge, between these two charges, and it is here. Suppose if I put the positive charge, you can see that it will be get repelled. This also will get repelled. Okay, so because of this, everything will get repelled and it will not reach the equilibrium. So the charge that I have to put should be the negative value. So let us assume that I put a charge which is minus q somewhere in between here. Okay, now if I put a charge, so before putting the charge, you can see that what will be the force. This is the force in this direction because of the plus q, because of the, it is the force from plus q on plus 3q, or we can say, let us assume that this is the point number 1 and this is the point number 3. So this is the force from 1 to 3. Similarly, you can see some force, this will experience some force here from 3 to 1. Okay, now I put the charge which is negative charge, I told you. So in such a scenario, this guy will attract my charge, and which is plus q, and also it will attract plus 3q. Okay, so if these forces be these forces, this is the force from 1, let us say this charge is at position 2, so this force from 1 to 2 and the force from 3 to 2, if both are equal, then the system will goes to equilibrium. Okay, so if both are equal, it will be in equilibrium. And also you can see that this force F12 is same here also. So because of this force, and this is the force F12, and this force, that means F31, both will be, if both will be same, the system will be in equilibrium. Similarly, the force F13 and F32, that means F13 and F32 will be same, and also these two forces will be same, and also these two forces will be same. If all these are same, the system will be in equilibrium. So we will see, first of all we will see what we can do, how to find this position of the charge. So before that, we will assume that the charge plus q is plus 3q is here and plus minus q is at this particular point, and the distance between them, between the point 2 and 3 is x. So the distance between the point, automatically between the points 1 and 2 will be d minus x. So it is very clear. So we can say that my forces F12 will be equal to F32, okay, at equilibrium, or we can say it is like with the definition 1 by 4 pi epsilon 0. What is F12? It is the force between plus q and minus q. So it is like plus q and minus q divided by the distance between them is d minus x, the whole square. This will be equal to 1 by 4 pi epsilon 0 into, what is that? It will be the forces, like it will be like plus 3q and minus q. So you can see that there are a lot of common terms in this. So we can cancel all these common terms. You can see this plus q, this q, and this minus q and minus q will cancel. So I will get the answer as 1 minus d minus x, 1 over d minus x the whole square is equal to 3 by x square. Okay, so it will be equal to 3 by x square. So by solving this equation, that means I can rearrange this equation like 1 by d minus x the whole square will be equal to 3 by x square, or we can say that d minus x the whole square is equal to x square by 3, or I can expand this 3 into what is d minus x whole square, d square minus 2 dx plus x square, which is equal to x square, and this is given as, let's say we have d which is given as 2 meter, so we will get 3 into d square is 4 minus 2 into 2 it is 4 into x plus x square, which is equal to x square. So we will get it as 3x square. If you simplify this, you can move x square to the left side, 3x square minus 12x plus 12 is equal to 0. So you can solve this equation, you will get the value of x as 3 plus or minus root 3, or the answer is 4.732 meter, and you will get another answer as 1.268 meter. So we get two solutions, that means x is equal to 4.732 meter and 1.268 meter. Now we will analyze these two scenarios. So let us consider the first scenario, that is plus q is here and plus 3q is here, and your charge as far as this distance is concerned, this is the distance d, which is equal to 2 meter, and x is the distance from the second or we can say the third charge. So this is my third charge, which is at distance 4.732 meter. So if this is, and also we know that it is negative. Now in this scenario you can see here that our minus q will be having the lines of force, like it will attract towards it, and so this will be the direction of the force. Okay, and because the charge 1 is positive and the charge 2 is negative, this will attract. Similarly, the same kind of attraction you can see, it will attract the plus 3q also. So same kind of attraction will be there. So you can see that in this scenario the equilibrium is difficult. Okay, so both will be attract together, so this and this will be 1 and 2 will be attracted, and also 3 will try to attract 2 also, 3 will try to attract 2 also. So this will not give you equilibrium. Okay, now we will see the second case, 1.268. so this is your plus q and this is your plus 3q charge. Okay, here, so it is separated by a distance d, and your x is d is equal to 2 meter, and the x now you have got your x now you have got it as 1.268 meter, 1.268 meter. Okay, and this is your charge minus q. Now you can see that minus q will attract plus q like this, and minus q will attract plus 3q like this, but q, that is the force, or I can see, number this 1, 3 and 2. So this is the force from 1 to 2, and this is the force from 3 to 2, but there will be other force also, and this will be balancing, and also so that Q will not move. So F12 will be equal to F32. Based on that only we have already calculated the X. We got this X based on this case, based on this criteria. Now when F12 because of the F12 plus Q will be moving towards 3Q, but 3Q will oppose plus Q in the opposite in another direction, that is given like this. So this is the force from 3 on 1, and similarly you can experience some force here. Similarly you can see some force here also, which is the force experienced by 3 from 1, that means force from 1 to 3. So you can see that the force which is in this direction, this will be same, both are same. Okay, the force in this direction is F12. So F31 will be equal to F12 at equilibrium. Okay, at equilibrium. So this will be a possible solution. That's why we will take only one solution. So now the second part of the question is to find the value of the third charge. So to find the value of the third charge, we will take this equilibrium condition. That means F31. What is F31? F31 is the force between 1 and 3. That means it will be equal to 1 by 4 pi epsilon 0 plus Q multiplied with plus 3Q, I will plus 3Q divided by the distance between them is actually D, so D square. This will be equal to the force between 1 and 2, which is equal to 1 by 4 pi epsilon 0 plus Q into minus Q divided by the distance. What is the distance between these two? It is nothing but D minus X, because this distance is X. So D minus X the whole square. So you can cancel some common terms. Plus Q and is cancelled. Then this 3, no, I cannot cancel this, sorry. So this is 3Q. Okay, now I want to find what is the value of Q. So I am going to find the value of Q. So what is Q now? Q will be equal to 3Q divided by D square, and I will take this here, so it will goes to the numerator, so D minus X the whole square. Okay, and there is a negative sign here, so I will put it here. So this will be the equation, and in our case what will be Q? Q will be equal to minus 3 times Q into D. What is D? D is 2 minus 1.268, that is X. 1.268 the whole square divided by the 2 square. Okay, so this is the answer. I hope it is clear to you.